Alright everyone, here's our door prototype video. You might be wondering why we're using text-to-speech rather than recording our own voices. It's for comedic effect. Anyway, enough of the exceptionally professional introduction. Let's get on to the video demonstration. So we decided to make the prototype out of Legos because they're great for modeling small systems. And because Gavin had a bunch of them laying around from when he was younger and still gave a shit. The door can be opened using a remote that can be secured to a nearby wall, or by an app on a mobile phone. Another suggested method of opening the door is simply to hire a doorman. The doorman would wait in this booth, but I don't have any Lego people, so we'll relocate the booth to a remote location with cameras to monitor people approaching the door. The door can be opened with a pulley, if needed. This can be either a primary or secondary opening mechanism to be used in emergency or in case of a power outage. The door simply folds downward to be flush with the floor. This creates a wide space that can easily accommodate carts, wheelchairs, and other things with wheels.
What do you think of a door more for a public entrance then, let's say, a loading dock?
I like the idea of the door opening downwards because the door frame becomes a wider open area. You will need to make sure there is a barrier that is similar to a drawbridge, so when the door closes or opens, the door doesn't hurt anyone. I do like a door that swings down and is flush with the ground in a medical facility though, because it is better for ambulance gurneys, wheelchairs, and carts.
The extra 2 to 3 inches that a door and hinges take up while it is open can go a long way. Do you agree?
Yes, and it can also be a tripping hazard for people with canes, wheelchairs and gurneys.
After the interview with Susan and teammates' family members, we started to design our final prototype. We stuck with the same overall design but combined several different ways to open the door. As you can see, we used a combination of a mobile app, remote and doorman, and a manual pulley system to make the door accessible to a wider range of people. If we were to use this in a hospital or some sort of medical pavilion or private establishment, employees can access the building with a touch of a button on their phone. There can also be a doorman or security guard that opens the door for those who need access. This creates more job opportunities similar to those that would get paid to pump people's gas in certain states. Finally, the door will have a manual pulley system, similar to a manual crank, which can open or close the door if any of the automated parts stop working. The doorman will have access to both the remote and the pulley system. The door will also have a safety barrier that opens and or closes during the process of the door going up or down. This barrier will be flush with the side wall so it does not become a tripping hazard. This door system is designed in a way where the door swings down and stays flush with the ground, allowing for easier entering and exiting of the building. By making the door swing down, there are no longer hinges that take up valuable space in the entryway and no track on the bottom that the door rides on, hence making the available space to enter wider. This door system also includes a mobile app that connects wirelessly with the door motor that will allow for quick and touch-free operation of the door. Of course, with any electrically operated equipment there must be some way to override operation in case of a malfunction. so there is a pulley system to manually operate the door. This is particularly useful in the event of a power outage. This door will be considerably easier to open and move rolling objects through, which is exactly what we had planned.